moving on to another concept. This is not related to even and odd. This is a new concept here. Determine where a function is increasing, decreasing, or constant. Now, the concept here is easy. When we talk about increasing, decreasing, or constant, it's pretty much what you'd expect. And as we talk about these, we're talking from left to right. So we're always looking from left to right, go in this direction. If we say increasing, decreasing, or constant, think like a roller coaster. If you're going this direction on a roller coaster, and here's the track you're on. Okay, here on this piece you're decreasing, you're going down. And then right here, from this point it turns, starts going up, right? So now we're increasing. Right here, where we're just staying flat, that's called constant. And then here, again, going down, we're decreasing. Okay, so just if you'll just remember, go to left to right. Seeing the pieces where you're increasing or decreasing or constant, it's pretty simple. Now the tricky part is how you write these answers. And the way that we're going to phrase these answers is we're going to use intervals. And anytime you talk about where something is happening on a function, you always answer in terms of x values. So when it asks where is the function increasing, decreasing, and constant, you want to answer, from this x value to that x value, it's increasing. So like, where is it increasing? Okay, starting at this point, going to this point. So between those 2 points, the function's increasing. Now we're going to phrase that answer by saying it's increasing on the interval. Okay, interval, and again of x values from -4, this x value, to the x value 0. Now I want to stress that this right here, -4, 0, that looks like an ordered pair, but this is an interval. Okay, that's saying between the x values -4 and 0. And we always, when we state increasing, decreasing, or constant, it's always open intervals. We don't include the points where it changes. So here at this point, -4, -2, it's between decreasing and increasing. So we're not including -4. That's an open endpoint there. To the x value 0, open endpoint there. So an interval of x values from -4 to 0. Again, not an ordered pair. I want to stress that this is not an ordered pair. The biggest thing you can get confused on with these questions is answering with ordered pairs instead of intervals. And it'll say on the homework, if you pay attention to the blue text under the answers where you're typing it in, it'll say answer using an interval. It'll say something about using an interval for your answer. So if you just pay attention to that, that'll help you make sure you get the correct answer typed in. Okay, so that's increasing. Where is this thing decreasing? Okay, right here, and also right here. You have 2 places where it's decreasing. So again, what are the x values? From -6 to -4. So decreasing, whoops. On the intervals. -6 to -4, and then also from 3 to 6, those x values. So we're going to join those 2 together. So we're using that union, that big U notation. Again, these are not ordered pairs. These are intervals. Can't stress that enough. And then the last piece, where is this thing constant? There's one piece here where we're constant. That's from the x value 0 to the x value 3. So there it is. Those are the intervals where it's increasing, decreasing, and constant. Okay. Next concept, as we talk about increasing, decreasing, and constant, we sometimes get what are called local maxima and local minima. And those maxima and minima words are just plural of maximum and minimum. So we're talking about local maximum and local minimum. And when we say local, we're talking about for one piece of the graph. So think of like the peaks and valleys of the graph. If you have a little peak in your graph somewhere, that point, we call that a local maximum. And I want you to notice this is the local maximum is f of c. Notice that's the y value. So when we talk about what the maximum is, that's our y value. Where the maximum is, again, if you're talking about where something occurs, you use the x value. So we say that there is a maximum at this c, and the maximum is whatever f of c is. So if that's a maximum, doesn't take much of a stretch of the imagination to see that this right here would be a minimum. This little valley in the graph. Again, this is a local minimum. Again, this local minimum is at c. The minimum is f of c. And this will make a little more sense when we look at an example here. So, first question for this graph, at what numbers does f have a local maximum? So in other words, where do we have a local maximum? Well, this little peak right here is a local maximum. So where is that taking place? That x value, x equals 1, is where that local maximum is. And then, of course, the follow-up question, what is the local maxima? Okay, that's the y value. So the local maxima, f of 1 equals 2. Okay, that's the local maxima. The y value there, 2, is the maximum. So where is it? It's at this x value. What is it? That would be the y value. Okay, what about a local minimum? Again, looking back at this graph, where do we have a minimum? That would be this little valley here and this little valley here. Notice we have two local minimum. The first one, where is it? It's at -1. The second one is at the x value 3. So two local minimum. Now what are they? That would be the y values for those 2 points. So the first one is 1. Second one, this point right here, has a y value of 0. It's on the x-axis. So those are the minima, 1 and 0. And then the last question, list the intervals where f is increasing and where f is decreasing. So let's see if we can identify those intervals here. I'm going to use red here for the intervals. Okay, the first one, where is this thing decreasing? This piece right here and this piece right here. So what are those intervals? Okay, for this piece right here, what's our left boundary? -infinity, right? It keeps going to the left further and further and further. So -infinity, and then it dead ends here at that x value, -1. And then for this piece, it goes from 1 to 3. Okay, so we're decreasing -infinity to -1 and 1 to 3. Now where are we increasing? That would be this piece and this piece. So that would be from here, that's -1 to the x value there is 1. Then here from 3 to keeps going to the right, so infinity. So -1, 1, and 3 to infinity. Okay. So we called those points local maxima and local minima because those were maxima and minima for single pieces of the graph. You know, if we go back and look at this picture, this was not, this point right here was a local minimum. It wasn't the lowest point on the whole graph, but just for this one little area, it was a minimum. Same thing for this maximum right here. It's not the highest point on the graph, but for this area, it is the highest point. And so we call those local maxima and minima. We can also refer to what are called absolute maximum and absolute minimums. And so what these are, it's the absolute highest and lowest points on the graph. And so you know, it's for the graph, what is the highest and the lowest point on the graph. And so let's see if we can look at these graphs and find the absolute maximum and minimum if they exist. And notice it says if they exist. We may not have an single absolute maximum or minimum. So for A here, is there a highest point and a lowest point? The first thing you notice is there's not any arrowheads on the ends of these graphs. These 2 points are dead ends. The graph stops. So for an absolute high and low point, we have a maximum and a minimum. So this would be the max, and this would be the min. And we can just kind of see that, and hopefully that makes good sense. Okay, part B. Do we have a highest point? Well, yeah, again, there's no arrowheads showing that this continues. It stops right there. That's the max. Now, does this have a minimum? Well, we have a low point here where it dips down. It looks like we might have a minimum, but notice there's a little open gap there, right where that lowest point is. So this is not a minimum. There's actually a hole in the graph where the minimum would be. So there's not an absolute minimum here. So there's no absolute minimum there. Okay, over here on part C, again, we do have a max. Is there a minimum? Well, there's actually several points there that could be considered a low point. And when we refer to absolute maximum and absolute minimum points, there can be only one minimum point. So here there's no single minimum point. There's an interval of points that are minimum points. So we don't identify a single minimum. For part D, is there a maximum? Well, I want you to notice for this graph, we do have an arrowhead here. So this thing keeps going higher and higher, which means there's not going to be a single highest point on this graph. It continues to increase. So here we do not have a maximum point. Do we have a minimum? Well, sure, this thing dead ends At 0, 0, that is a lowest point. So we can call that an absolute minimum. And then last graph here, is there a max? Well, we got an arrowhead, so there's no maximum. It continues higher and higher. Is there a minimum? Well, notice there's a hole right there where the minimum should be. So in this case, there's actually no max or min. No highest, absolute highest or lowest point. Okay. Still on the concept, the idea of local maxima and local minima, and increasing and decreasing, we can actually use our calculator to also figure this out. And so let's kind of look at this. It says use a graphing calculator to graph this function for the x values between -2 and 2. So let's do that real quick. So 6x squared minus 12x plus 5. And we want to graph it between -2 and 2. And so to make that happen, we can go to our window and change the x min to -2, the x max to +2. If we graph that, there is our graph. So there it is. It says approximate where f has a local maximum and a local minimum. Now we can tell there's probably a local minimum right here. And the way we can approximate that is by using our trace function. If we can actually trace this, and if you'll hit trace and then start moving to the right, you'll see eventually we can move that x, and we're looking for a minimum here. We want to see how low the y value can get. And I'd say that y value, -0.997, has an x value of 1. If we go to the left a little bit, 0.97 still has that same y value. So I'm going to say that minimum is somewhere around an x value of 1. Let me just type in a 1 and see. Okay, at x equal 1, we do have a minimum at -1. And so I would say that's a minimum. It's a local min. Does it have a local max? Well, this is a parabola, right? So doesn't this continue to get higher on both ends? So we would say that there is no local maximum. Where is f increasing and decreasing? Okay, again, where is it increasing? We're dealing with, let me just sketch a quick picture of this graph here. It's this parabola shape. And this point right here is 1, -1. So it's increasing on the right hand side. So increasing, again, where we answer with x values from 1 to infinity. Keeps going, increasing to the right. And then if we want to talk about decreasing, we get a different color here. That would be this piece right here, wouldn't it? So from -infinity to +1 is where it's decreasing. And so we can use that calculator to get a graph and use the trace to figure out where those max and mins are. Gives us a nice little picture of what we're dealing with there, and we can see those peaks and valleys pretty well.